Okay, here we go with our first lesson talking about objects. This whole unit deals with objects, so we're getting introduced to what those things are and how they play a bigger role in object oriented programming. So, Java and most modern day programming languages use a design approach known as object oriented programming or just simply OOP. The counterpart to this is procedural or functional programming languages, which are more so used for like math. Object-oriented programming is a programming language model that focuses on objects instead of logic, data, or procedures. Here is the general concept. Objects are just a way to collect data and keep it together. I'll give you just a quick for instance. Let's say that I have a string and then I have a double, and I want those two things to be associated with each other. Well, what I'm going to do is wrap them up together in something known as an object. That way, wherever they go together. There's some advantages and disadvantages, and we'll dive into what these things actually mean. But an advantage of OOP is that there's recyclable code and it's intuitive. Disadvantages being it consumes more space than traditional programming models and there's a higher setup cost. So let's talk about recyclable code or reusability. In OOP, multiple classes can be used to segment a program. Those individual segments, those classes, can be reused in other programs, thereby reducing the need to rewrite code. My idea is to, or the idea of OOP is to write code that is generic and segmented. That way I can reuse it in multiple programs and multiple applications. OOP is intuitive. The whole idea behind object-oriented programming is just to model the real world as closely as possible. And so when you get deep in the weeds and you want to know how should this section of code actually work, what is the relationship between these segments, these multiple classes, it's typically answered by just observing the real world. As long as we just keep going forward with real world observations, it should stay intact. This philosophy is arguably more intuitive than traditional models, especially when we start working on large projects. So when you get into really big projects, that's where OOP kind of helps you keep things synchronized because the relationship between the classes should just be the same as the relationship in the real world. There are some disadvantages with OOP. Each object has to be stored in memory, and space is limited, more so in the years prior to OOP than the rise to prominence. That example that I gave earlier, where you take a string and a double, and you want them to be associated with each other, so you wrap them up together, well, that string is going to take up the space that it takes up, and the double is going to take up its space. Then you have this wrapper. Well, that takes up space, right? To actually, you need a bit of data to basically say that these two variables are linked together. And that's where the extra space comes in. Not a big deal these days, but you got to keep in mind whenever OOP was coming to prominence, whenever it was introduced, space was incredibly limited, so this used to be a much bigger deal. It's still true today. We still consume more space with OOP than we do with functional and procedural programming, which is why we see functional and procedural kind of used with math, where efficiency is a little bit more important, but when speed is not super important, whenever space is not super important, OOP makes a lot of sense. There is a higher setup cost, right? I talked about how you're supposed to model your code after the real world. Well, that takes some pre-planning, a little bit, you know. Yes, those relationships between those code segments are basically, they already exist in the real world and you're supposed to be modeling after that. But you got to even think about, well, what things do I want to represent? There's a higher setup cost there, which is largely why most of the stuff that we've done so far hasn't really dived into this, because the stuff that we're writing, it doesn't need it. A lot of the things we've done have been calculations. We've basically been using Java, an object-oriented programming language, as if it were a functional programming language. In essence, everything in the real world can be represented in Java using objects. All objects can be modeled via three characteristics. We're going to have a state, which are attributes or characteristics about the object. We can have behaviors. These are actions that the object can perform. And lastly, we're going to have an identity or a name that manifests itself in code via variables. Here we have a dog. When I created these slides, this was the world's biggest dog. tell me about its state. Give me some attributes, some characteristics of the dog. You might say it's big. You might say the fur color is gray. I would ask, being a dog person, I would want to know, do you know the breed? This is a Great Dane. We have this little yapper dog. Again, when I created these slides, this was the world's smallest dog at the time. Give me some attributes. Right? It's tiny. What's the fur color? It's kind of this white, brownish. What's the breed? Okay. Again, those are some attributes, some characteristics. Other things I might be curious in is, what are some behaviors? Right? This dog can like run and jump and eat a lot, as the case may be. What are some behaviors of this dog? It can yap and jump not as high and accidentally get kicked. Give me some attributes about this dog. It's got a brown cinnamon fur color. It's probably like a medium size. The breed of this dog happens to be my favorite. It is a Vizsla. What are some behaviors of this dog? It can run and jump and eat and point. While all of the dogs in our previous slides are varying breeds, each dog has a breed. Right? We got a Great Dane, a Yapper dog, a Vizsla. Likewise, each dog has a weight, a fur color. They all have these attributes. While they may be different, they all have them. Likewise, with their behaviors, they all eat, sleep, and bark. Maybe slightly differently, but they do those behaviors. So this is what we're looking for. When we're talking about modeling an object, we want to know state, we want to know behaviors. So what are some other examples of objects? I want you to kind of think of some on your own. Maybe you want to model a person. Okay, well, what states do people have? What behaviors do people have? Objects are instances of a class. So how do classes fit in object-oriented programming? Objects are instances of a class. In fact, the word object and instance are interchangeable. Now, this is kind of a hard concept. Let's explain. Essentially, a class is the template or blueprint that is used to construct individual objects. An analogy that I used to use was a cookie cutter. I would literally get a cookie cutter and make cookies out of Play-Doh. But imagine you have like a little gingerbread man cookie cutter. You press it into cookie dough, right? That's your class. The cookie cutter is the class. But I could possibly use different dough. Maybe I have dough that has chocolate chips in it over here, and then maybe I got dough that has like raisins in it over here, right? Those cookies are going to be different, but their shape is all the same, right? The cookie cutter is the class in this analogy, whereas the actual cookie that gets produced, that's the object. A class defines an object's state and behaviors. Right? State is, we'll dive into it. Let's recap. What programming model does Java use? Object-oriented programming. Name one advantage of OOP. I gave you two. I just want one. Well, I would say that OOP is reusable. Right? It creates recyclable code. And it's intuitive. Name one disadvantage of OOP. I gave you two. I would say there's a higher setup cost to OOP, and it's going to take up more space. It consumes more space than traditional programming models, that is procedural or functional, and there's a higher setup cost than traditional programming models. What three characteristics are needed to model an object? We're going to have state, behaviors, and identity. State are attributes or characteristics. Behaviors are actions. And identity is just simply the name. Again, the way this is going to manifest in code is a variable, effectively. What is the difference between an object and a class? Ooh, this one's hard. It's probably easiest to answer this by saying what a class is. A class is the template or blueprint from which an object is created. Think your cookie cutter. Whereas an object is the thing that is actually created. We would say that an object is an instance of a class, right? When I make a little gingerbread man cookie, it is an instance of that cookie cutter. A class defines which two characteristics of an object. That's going to be the state and the behaviors. That's going to wrap up this introduction to object-oriented programming. I'll catch you in the next video.